So it's recording now. Mhm. Yellow. So we're going to work more on logical connectives, compound propositions, and the truth table. So as what I was saying, I'm going to give propositions or statements on mathematical concepts. So all of these statements or propositions are mathematical concepts, and we can place a certain value for each proposition. Okay. And considering this truth table, so we will identify first each proposition here, and then we will try to combine them and find out the truth value. So 3 is less than 5. So we know that it's a true statement, right? So we know that this is true. Oh, wait. So this is true. Okay. A pentagon is a five-sided polygon. So this is a true statement again. 4 is a prime number. So this is false. So how do we define prime number? So a prime number, the factor of a prime number is the number itself and 1. So we know that the other factor of 4 is not just 1, no? So in fact, 2 is factor of 4. So we cannot consider 4 as a prime number. Instead, 4 is a composite number. Okay? And 1 is not a prime number nor a composite number. Okay? So because 1 is a special number. Any number multiplied by 0 equals 0. So this is true. Vertical angles are congruent. So what are vertical angles? So vertical angles class is the result of two intersecting lines. Okay. And the other term for vertical angles, we call these as opposite angles. So the two angles here are congruent because these are vertical angles or opposite angles. And this pair of angles are congruent also because they are opposite angles or they are vertical angles. So this is true. A parallelogram is a quadrilateral. This is true because a parallelogram class is a special quadrilateral. A quadrilateral is a four-sided polygon. Okay, polygon. Okay. Now, this is also four-sided polygon. That's why this is quadrilateral. This is special because a parallelogram has two pairs of opposite sides, two pairs of opposite sides parallel. Yun, parallel. Okay? So, for example of parallelogram is a square, um, a rhombus, yan, and a rectangle. So, these are parallelogram kasi meron siyang two pairs of opposite sides parallel. Okay. So, hindi ko lang siya na-draw ng perfectly, ha. and this one as well. And at the same time, these three figures are quadrilateral. So these are special quadrilaterals. So statement U is true that a parallelogram is a quadrilateral. Now we're going to combine these statements using the connectives, and we're going to identify the truth value. Okay? So P or Q. What's the truth value of P or Q? So P or Q, so how can you reconstruct P or Q? Anyone? You just recite what's P or Q, and then later we'll identify the truth value. You can raise your hand virtually if someone wants to answer. Sige, I'll start with P or Q. So P or Q, 3 is less than 5, or a pentagon is a five-sided polygon. So that's P or Q. So how about its truth value? What is the truth value of P or Q in our example? Anyone? What statements P and Q are true? So P or Q is true, right? So the condition in order for P or Q to be true, either P or Q must be true. In that example, actually both P and Q are true. So P or Q is true. Okay? How about P and Q? So P and Q in our example statements can be constructed using the conjunction and 3 is less than 5, and a pentagon is a five-sided polygon. And its truth value is true. Again, both statements P and Q are true. And the rule for P and Q, both statements must be true. So P and Q is true in our example here. So how about if P then Q? So when we say if P then Q in our example statements here, if 3 is less than 5, comma, then a pentagon is a five-sided polygon. So that's how we construct if P then Q in our example statements here. And if P then Q is true. Okay? For if P then Q, we only have false statement here if the conclusion is false. Whatever and the premise is true. So it will be a false statement. Otherwise, everything must be true. True. So if P then Q in our example is true because both P and Q are true. So do not get confused, ha? Okay, so how about P and R? So for P and R, a pentagon is a five-sided polygon and 4 is a prime number. So what is the truth value of P and R here, class? Anyone? Anyone? Yes, Karina.
P,
What's your answer?
P, the 3 is less than 5.
It's either true or false. So what's your answer? Um,
False.
yes, it's a false
False.
statement because um, statement R is false. So our rule in order for P and R to be true, both P and R must be true. Since R is a false statement, then P and R is false. That's right. Okay. So how about if If S, then, ano yun? Then R. So this is, if any number is multiplied by 0 equals, any number, or we're going to construct this using if S then R. So we have if any number multiplied by 0 equals 0, comma, then 4 is a prime number. So that's how we construct if S then R here. And what's the truth value for this? Anyone can unmute his or her mic. So you just refer to this table. And we have SR, TF. So TF, so this is a false statement. Okay? The premise is true. Statement S is true. And then the conclusion R is false. So it's TF. So it's a false statement. Okay? So how about P, either P or Q? So we are using the exclusive or connective here. Okay? Either 3 is less than 5, or a pentagon is a five-sided polygon. So what's the answer for this one? So you have to refer to this table. So we have true, true, no, for PQ here. So there's an answer in the chat. So it's a false statement. Correct, Carmel. Because either statement should be true. Okay? Since both are true statements, then this must be a false statement. Oh, nagmamadali yung slide natin. So this is false. Okay? Um so how about T or U? So this is vertical angles are congruent, or a parallelogram is a quadrilateral. So this one is a true statement. Okay? So the rule again for the connective or either of the two statements must be true in order for that to be considered true. And since both are true, so that will be considered true pa rin. No? Either or both statements must be true in order for the connective or to be considered true. Okay? Any question on this? So again, let's work on the negation of statement P. So using this one. So here, again, 3 is less than 5. So this is a true statement. This is a true statement. This is a false statement. And this is a true statement. So working on the negation of P. So negation of P is, it is not true that 3 is less than 5. Okay? Rewrite natin 3 is less than 5. Or simply, you may express that as 3 is not less than 5. So, since we have made use of the negation or the negation phrase, it is not true, then negation of P becomes a false statement. So, originally, P is true and its negation must be false. So, how do we construct the negation? It is not true that 3 is less than 5. So, it's a false statement then. Okay. So for negation of Q, it is not true that a pentagon is a five-sided polygon. And this is again a false statement. False ito, no? Because a pentagon is a five-sided polygon. And the negation of R, it is not true that 4 is a prime number. So this is a true statement. Okay? Because originally, statement R is a false statement. So its negation must be true. Okay, so for S, negation of S, it is not true that any number multiplied by multiplied by 0 equals 0. So this is a false statement. Okay? So I'm just writing in statement the negation of each statement here and then provide the truth table, because in your next activities you might be doing the same thing here. Construct a truth table for each of the following compound propositions. Okay, so we're going to construct a table this time. So P, since isang statement lang yung comparison natin, so we have negation of P. So the table that you're going to construct will lead to um, the truth value of the given compound propositions. And then we can now have P and negation of P. Since we only have one proposition here, so the possible truth value of proposition P is either true or false lang naman. So if statement P is true, this must be false. If statement P is false, this must be true. So P and negation of P. So we're going to make use of the connective and. So the truth value of P is true, while the truth value of negation of P is false. So P and negation of P, so combining the two here, the two propositions with this truth value using the connective end will give us a false value. Likewise, this is also false. I think I was able to explain this during our previous discussion. Okay? And this is about contradiction, if you remember. So, the combining a statement using the a statement and its negation using the connective end will always lead us to contradiction, because one is true, the other one is false. So if we combine two contradicting statement, true, false, false, true, then we'll come up with a false statement. So this is now the truth table that we are asked to construct. Now, since we are using two statements PQ here, so we're going to expand the table. Like, we're going to create four rows, providing P is true and false, Q as true and false also. So we have P, okay. So true, tapos true, and then false, false. And then for Q, we have true, false, true, false. So we need the negation of P as well as the negation of Q. And then the last is negation of either negation of P or negation of Q there. So negation of P for the first row. So this is false, false, true, true. So where did we obtain false, false, true, true? Initially, its statement P is true, so its negation is false. Another true statement for P, so it has to be false. False, true, false, true. Likewise for Q, since this is true, its negation is false. Since this is false, this must be true. Since this is true, this must be false. False, true. Now, we are comparing this to propositions. And we will connect this and we will combine this using the connective exclusive or. So the rule for exclusive or is that either of the statements must be true. Either only of the statement must be true for that to be considered true. Otherwise, that will be considered false. Okay? So, since both are false here, this must be a false statement. No? Since either here is true and then the other one is false, so this is, wait. So, this is false. Sorry. So, dapat either is true or false to be true. So, for the two here, so this is true, this is true, and this is false. So, this is the truth value of this. No? Yan. And for this one naman, eto yon. But we need to come up with this one for us to arrive with the truth value. Okay? And that's how that's how to construct a truth table. Okay. If P, then negation of Q. So, we are using two statements here. So, P, Q. So, this is true, true, false, false, true, false, true, false. And then, we need negation of Q. So, if this is true, this is false. If this is false, this is true. If this is true, this is false. True. Okay? Lagyan na lang natin ng guhit later. Okay. And then, the last column is if P, then negation of Q. Negation to. Okay? There. So, take note that in the implication table, EP then Q, there is only one false. EP then Q will be a false statement if the premise is true and what's this? The conclusion is false. So, this will come up with a false statement. Otherwise, everything will be true. So, kung TF siya, hindi nakikita si TF. If it's TF, okay, kung TF, false siya. And then the rest will be true. Okay, so let's just locate and we are comparing this and this. Take note. Kasi if P then negation of Q, di ba? So where is TF? TF, ito si TF, no? So false ito. So everything is true now. Kasi si TF, F lang naman eh. And then the rest will be true na. Like, true, true will be true. False, false will be true. False, true will be true. So you just look at TF and TF equals F. And the rest will be true. Okay? Question on number 3. Dito naman, so we have P and Q pa rin. PQ. So, we have true, true, false, false. And then true, false, true, false. Okay, so we need P or Q. And then we need P and Q before we come up with P and Q. If P and Q, then if P or Q rather, then P and Q. So we need to identify P or Q. So P or Q, this is true because both are true here. The other two here will be true kasi either is true. But the last is false based from the truth table for connective OR. For end naman, true, true lang. This one is true. Then the rest will be false. Kasi requirement again for end, both statements must be true. Okay, so we are now going to compare this and this using the implication if P then Q. Okay, parang ganyan. So since we are using if P then Q, we will still locate the TF, this one. So using the two here, no? So this is your premise and this one is your conclusion. Where is the TF? So this is TF. So this is false and the rest will be true. Okay. Because we are using the main operation implication. And the rule for implication is just the the implication statement will be false if the premise is true and then the conclusion is false, right? And this will lead to a false answer. So we just locate where is the TF here. Okay, there's a chat. Third one for number 4 ba? Are you referring to number 4, Carmel? Wait. This one is true. Our rule for implication, if P then Q, let me rewrite the the truth table for that. This is P, or shall we, let's just go back with this one. Wait. Here. This one is implication. Uh-huh. Right? So this is the TF. So that's why we come up with F here. So everything is true. Whatever the truth value of the premise and the conclusion. So what we just have to watch is the premise is true and then the conclusion is false. So if P then Q will be a false statement. Otherwise, the rest will be true. Kung true yung statement, regardless kung true or false yung kung true yung statement, it should be a true conclusion. If it's a false conclusion, then it must be a false statement. Now, if the premise is false, regardless if the conclusion is true or false, it will still then be a true statement. Now, going back dun sa dun sa latest natin, this one, right? So, this is false and the rest is true because this is the TF. Okay? Regardless of the value of the premise and the conclusion, we'll come up with the true statement. As long as um the premise, if the premise is true, the conclusion should not be false. And if so, this will be a false statement. Now, going back to the chat, why isn't the third one false as well? It's a true statement because the premise is false regardless uh if the premise is false, regardless if the conclusion is true or false, it will be considered as a true statement. Okay, so clear na, Carmel. What we will follow is the TF. If the premise is true and then the conclusion is false, automatically that is false. Otherwise, everything is true. So, if it's a true premise, it should be a true conclusion for that to be true. Now, if the premise is false, whatever the conclusion, whether it's true or false, it will still be a true statement. So you just have to watch out for the TF. It's TFF, something like that. Okay. Okay, show that there's another chat. Okay, welcome. Show that the following are logically equivalent. So again, when we say logically equivalent, they should have the same truth value. No? So ito may table na tayo. Hindi na ako mahihirapang magguhit-guhit. I'll change the color to black. Okay. So this is P, this is Q. Okay, so if this is true, true, false, false. So this is true, false, true, false. Now, we're going to work on P or Q muna. So, P or Q, so using the connective or, this is true, true, true. Ito lang yung false kasi both are false. So, the requirement for P or Q to be true, either or both statements P and Q must be true. So, that's why the first three here are true. And then we only have one false here. And then we're going to work on the negation of this kasi we have negation of P or Q. So, we will just negate whatever the value of P or Q. So, this is true. So, this is false. True. This is false. True. This must be false. Oh, so this is true. Ayan. So we just negated whatever the truth value of P or Q, and that's negation of P or Q. Ito na siya. Now, we're going to work on negation of P and negation of Q for us to identify what's negation of P and negation of Q. Okay? So negation of P, so this is false, false, true, true. So this is based from this one, the negation of each statement here. And then the negation of Q, this one naman. So we have false here, true, false, true. And then we will combine negation of P and negation of Q using the connective end. So connective end, for that to be true, both statements must be true. So, eto lang ang true natin. Kasi both statements here are true. And then the rest, ito false siya. So, pares na false. And then either here false. So, false din ito. Now, we're going to compare the two if the two are logically equivalent. No? So, ito yon. And this one. They are logically equivalent if they got the same truth value. And they have the same truth value. So, we can say that saan na yun? Negation of P or Q is logically equivalent to negation of P and negation of Q. Okay? So this one is therefore. Question? Okay, we're done. Do you have question, guys? So we work.
Ma'am,
Yes, dear.
yung dun sa huling ano niyo po, saan po, given na po ba yung ano, or and na ano, yung bago niyo makuha yung the rest po?
Ito, wait lang ha. Balikan natin. Sa last part ba, Cheryl?
Yes, ma'am.
Sige, sige. Um,
Yung sa PNQ, tapos yung PN or Q
lang,
po.
hindi siya na-save. Anyway, wait lang. Here, hindi. I-identify natin siya. So, we will complete the table. Pero kasi, wait lang ha. Ayun, buti naman na-keep yung annotation natin. Ito yung last, no? Ba't ba beginning? Sorry, sorry. Yung binigay kong truth table sa inyo, meron na siyang ano eh, will serve as your guide in constructing this. If you're asked to construct a truth table and then you are given two variables, you will start with this. Dito kayo magsisimula.
PNQ po.
P and Q. And then, for instance, kasi you're asked to show, you're asked to provide a truth table to show that the two are logically equivalent. So, iisa-isahin mo siya. Like, you begin with P or Q. That's why we started with P or Q here. We know that this one is negation of P or Q. So, if we are able to get whatever the truth value of P or Q, makukuha natin yung negation niya. Ayan, nilagyan lang natin. Binaliktad lang natin siya. True, false, true, from the idea of the negation. And then here, kasi negation of P and negation of Q naman siya, we need to get negation of P and negation of Q. So, kaya tayo gumawa ng negation of P, negation of Q. Now, this does not follow order naman yung table na dapat. Well, si P and Q yung una lagi. Tapos here, it does not ano naman na necessarily na mauuna si negation of P, negation of Q, as long as you will be able to establish that the two main propositions here are equivalent. So, eto, napakita natin yung truth value niya. So, we work on the next naman. Since negation of Q and negation of P and negation of Q are involved, so we work on negation of P, negation of Q. So, we base this from the statements PQ. So, ito si F. Ba't siya F? Because of this. This is T. So, its negation is F. Kabaliktaran lang. True, naging F. Then F, naging true. F, naging true. Likewise with negation of Q. Kasi originally, this is true. So, naging F siya until true. Now, etong dalawa, we compare the two using AND. Ito. So, ano yung rule natin for AND? Dapat both statements must be true. That's why, isa lang ang true dito. Kasi, the two are true. And then the rest, either is true. So, false siya. And then, both false. So, definitely false siya. Now, the instruction here is we're going to show that the two are logically equivalent. So, that's why we constructed a table. And then, they are really equivalent kasi parehas yung value nila. Dapat lahat parehas, no? So, hindi pwedeng isa lang. So, 4 must satisfy. So, the 4 must be the same with the other one for them to be considered as logically equivalent. They are logically equivalent because they got the same truth value. So, that's the idea. Okay? So, andito naman yung yung guide natin. End ko to ha. Balikan ko. Dito natin siya kinuha. Eto. Ito si end, yung condition niya. So, ito true lang, the rest nag-false siya. Pagka or naman, 'di ba, basta either of the statement is true, we'll consider that true and both. Now, both or either will be true. So, both true, so true rin si or. Either dito, true, kaya true din. Pero here, it's false kasi both are false eh. So, one should be true or both should be true in order for this to be true. Yung exclusive or naman, dapat either lang true or false, parang ganon. Kaya ito true, kasi either is true. Either is true. Tapos this becomes false kasi parehas na true. Parehas na false. Hindi pwede. The idea of exclusive or is isa lang ang totoo dapat. So it's either this must be true or this must be true. If both is true and if both are true and both are false, it will be a false statement under the exclusive or. Sa if then naman, if P then Q, basta si TF lang hanapin nyo. TF, ito si TF, 'di ba? False siya. The rest true na. Ngayon, 'pag true, if the premise is true and the conclusion is false, false siya. Kasi if the premise is true, the conclusion should be true. Kaya siya true. Now, if the premise is false, regardless if the conclusion is true or false, it will still then be a true statement. So, yun lang yung mga palatandaan natin. Okay, plus dapat alam nyo yung truth value ng statement. Anyway, madali nyo naman ding i-google yun eh for mathematical statement to be true. Hindi man ako magbibigay ng, I will not give a difficult mathematical statement that need to be proven for you to know it's true. Mga statements like this lang naman yung ibibigay ko. Can be one more example for negation. The idea of negation is just negating the truth value. Like ito, mga negation to, 'di ba? Originally, statement P is true. 3 is less than 5. So, it's true. Kasi 3 is really less than 5. If you negate that statement, you add a negation phrase or you just add the word not. So that becomes negation of P. It is not true that 3 is less than 5. Or you may rephrase this as 3 is not less than 5. But you know that 3 is less than 5, di ba? So, the negation of this statement will be a false statement kasi originally, this statement is true. Pag binaliktad mo siya, when you negate that, maninegate mo rin yung truth value niya. So, false na siya. When you say, it's not true that 3 is less than 5. So, it will be a false statement then. Parang ganun lang siya. Babaliktarin mo lang. A pentagon is a five-sided polygon. So we know that a pentagon is a five-sided polygon. So it's a true statement. But when you negate that, you said that it's not true that a pentagon is a five-sided polygon. So its truth value is false because you know that it's false. Na we know that a pentagon really is a five-sided polygon. The idea of negation is negating the statement. Babaliktarin mo lang siya. But when you negate the statement, the truth value will be negated as well. That's why, ito yung truth table natin for negation statement. If the statement originally is a true statement, you negate that, its truth value becomes false. If a false statement, when negated, that becomes a true statement. Asan ba dito? Ito, si R. 4 is a prime number, so it's a false statement. When you negate that, it is not true that 4 is a prime number. That becomes a true statement. Kasi false yung original truth value niya. So you negated that, binaliktad mo rin yung truth value niya. I hope this is clear. I'll stop sharing. Question? Anyway, this is recorded, no? So, um, maiintindihan niyo naman, mas maiintindihan niyo when you go back to the video and to the discussion note. I'll provide the discussion note also. Question?
Kailan